Yeah,
Hello, Piyush sir.
yeah.
Can you hear me?
Yeah.
Okay, so the mic of students has been changed to mute by default. And if they have any
Okay.
questions, they will raise their hands. And if you want, I'll unmute them.
Okay.
Okay, sir. And chat as well, we have some restrictions. If they want, we'll enable them.
Oh, let's start now. It's already 5:05. Okay. Yeah. Uh, is my screen visible? And every one of you, are you able to hear me clearly now? Okay. So I request everyone to go to this menti.com and use this code 774 to join this Mentimeter. Okay. Yeah. So today we'll discuss, initially we'll discuss about concepts of week three, and then we'll take up doubts from, if you have any other doubts from the concept or any other thing, we'll discuss. I'll not, warning you guys that I'll not take up any operational issue. Okay. For operational issues, you have to write mail. Just let me know in the chat that am I audible clearly? Just let me know one.
Yes, you're audible, Piyush. And one
Yeah.
thing, do you want me
Yeah.
to switch on the mic of students, or shall I wait?
No, you just keep the chat section on. I'll read that from here. If anyone have any severe issue, I'll let them.
Okay, okay.
So let's begin with this. I hope all of you have already joined. As I can see, there are almost 300 participants and only 155 have joined the meet. Okay, that is this Menti session, this Menti.com. Okay. So I urge all of you to join this Mentimeter to keep the session interactive. So in this week, professor have discussed the paradigms of learning. Okay, what are the different paradigms of machine learning? So what is this paradigm? Slowly, one by one, we'll delve into the topics. Okay. First of all, like, have you all seen the lecture recording that was provided in the portal under week three? Yeah. So I can see like almost more than like half of the almost 75% of the students have seen the lecture. Yeah, for responding to this question, you guys can like instead of yeah, Mentimeter's code is just go to menti.com and the code is 777448640. You can see on the screen, it is already there. And for responding those question, you guys can use that Mentimeter instead of replying on the chat. Just keep the chat for very specific kind of doubt. And I will urge all of you don't share any like personal information or personal detail or any kind of any like talks that are not related to these sessions. So I'll urge all of you to avoid this discussion. Else, like the chat section have to be turned off. Okay. There are, as discussed, those who have seen the lectures, well and good. The paradigms of machine learning, broadly, there are three paradigms that are being discussed by the professor, right? Supervised learning, unsupervised learning, and sequential learning, correct? Okay. So, what is supervised learning? Okay. One more important thing that we'll deal with mostly these two things. Okay. That is supervised learning, unsupervised learning, and we will not deal with sequential learning in this course. Okay. Like you have to understand very clearly what is supervised learning and unsupervised learning. Okay, to do well in this course. Okay. And this is, I would say, very easy. Okay. So if you have watched the lecture, well and good. If you haven't watched the lecture, okay, I'll share some slides from my college. Okay. Yeah. I hope this is visible to all. Yeah. So this, what do we mean by sorry. Yeah, so this is the important part, paradigm. Okay, all these are not necessary, I would say for you guys. These slides are just a part of my like part of my something that I have made for myself for my college. And these topics of these slides are actually like an intersection with the course that you guys are learning, right? So that's why I am using these slides. Okay, so see, the first topic was the paradigms of machine learning, correct? And under these paradigms, there are supervised learning, unsupervised learning, supervised learning, unsupervised learning. Okay. And then next was your sequential learning, correct? These three terms you guys are being introduced, right? Okay. So we'll see one by one what each of this means. Okay. So first, let's understand what is like what are what basis these three fields are being separated. Okay. The first thing is that machine learning and encompasses several paradigms, each defined by the nature of data available and the type of task to be performed. The primary paradigms include supervised learning, unsupervised learning, and sequential learning. These paradigms guide the design and application of algorithm in various real-world scenarios. So what does this? We have a problem, real-world problem, right? Or a real-world scenario. We have to solve this problem using machine learning. Now, how can I decide whether it is a supervised learning, unsupervised learning, or sequential learning? So the nature of this problem will be decided by the data. Okay, will be decided by the data that is available to us and the type of task or the type of problem that I need be solving, that I will be solving. Okay, type of task to be performed and the kind of data available to me. Okay, so first type of problem is supervised learning. Okay, so what happens in supervised learning? The algorithm or our model, the machine learning model that we will be building, is trained on labeled data set, where each input is associated with a corresponding output. The goal is to learn a mapping from its input to output that can be generalized to unseen data. Okay. In this, we have data set. Okay. Let's say the data set comprises of 100 data points. Each data point is, let's say, image of a, let's say image. As of now, let's say each of the data point is image. So my entire data set contains 100 images, right? Is this clear? So this accumulation of all these 100 images, I will say as data set. Is that clear to all of you? Is this clear for all of you? What I mean by data set. Data set means accumulation of my data points. In this case, my data points are, let's say, image. Let's say I have 100 images. Okay, each one of image is my data. Okay, and accumulation of 100 images, I am telling this is data set. As I told, I have to decide the nature of my problem based on the data available and the type of the task I need to perform on this. So this 100 images are my data. Okay. And let's say this is an image of a cat. This is image of a cat. Let's say this is image of a dog. So these are my labels. Okay. These are my labels corresponding to each of the image. Here. These are my labels corresponding to each of the image. So each of the image. So I have data and I have label corresponding to it. So what are the two things here I am having? I am having data. I'm having data. Okay, and corresponding labels. Okay. So in supervised learning algorithm is trained on the labeled data set. So this data set is my labeled data set, right? Because I have label corresponding to each of the image. That's why this is a labeled data set, where each input is associated with a corresponding output. So this is my input. This image is my input, and my corresponding output is either cat or maybe dog. So there are 100 images. I have 100 images and each of them are labeled with either cat or a dog. Okay, so my corresponding possible output is, it could be either cat or it could be either dog. Correct? Now, the goal is to learn mapping from input to output. So my input is this image and my output is this level. And I have to learn such a function, f of x. If I talk in terms of mathematics, it should be f of x. This f of x should be producing me some output y hat. So this x is nothing. This x will take the input data. This x will take the input data. Okay. That is the images in this case. And based on that, it will try to find the mapping that is y hat. And the result, and the thing that I will learn, the learning from this input to output is called my model. This is called my model, machine learning model. The terms that I am introducing, is it clear? What is input, what is output, what is label? Like output is usually label, and what is like machine learning model. Okay. Now, as I see, the goal is to learn mapping from input to output that can be generalized to unseen data. So what this part is, this I'll discuss little later. As of now, you can like ignore that part, just like generalization of unseen data. You can ignore it. Okay. Now, supervised learning is, to summarize, supervised learning is something, let's say we have level data Okay, so level data consists of input and output levels. Okay, and we have to find the mapping from input to the output. To summarize, this is what supervised learning is. Okay. Now, as the name suggests, unsupervised learning. So in this unsupervised learning, like in this supervised learning, we are asked to do something. We are asked to build a model, right? That will output something, that is f of x that I have shown. It will give me some output y hat, right? And the function is nothing but f of x. This y hat function is nothing but f of x. That is, x will be the input that I will be taking, and based on that function, that f is a function, right? On the input x, it will do some computation, and it will give me the output y. I hope that makes sense. Yeah. So that function can be, what kind of function I should be performing on that? That could be either classification or regression. Ignore these two. These two are out of the scope of this course. Okay. Ranking and structural, and just ignore this. This is out of this scope of this course. Okay. So the thing was classification and regression. Going forward, we'll learn in more detail about classification and regression. So supervised learning means we have data set, a level data set, we have to perform some function on it, and based on that, I have to produce some output. Okay, so that's it. And there are two kinds of supervised learning. One is classification, another is regression. Up to this, is it clear? Before I move into unsupervised part. Is it clear to all? Now, moving to unsupervised part. Unsupervised learning deals with unlabeled data. That is, there is no label associated with the data. We just have image. Okay, we don't know. Maybe some, it may be image of some cat. Let's say I have image of cat and dog. Okay, I have image of cat and dog, but the image are not that much clear. I have image of cat and image of dog. I have, let's say, 100 images in my data set, and these are not labeled at all because the image are not that much clear. That's why they are not labeled. Let's say it can be either of the cat or can be either of the dog. We don't know, like, is this image of a cat or it is of dog. Okay. So once I learn unsupervised learning algorithm, okay, I don't have any label associated with the image. Once I learn unsupervised learning algorithm, once I run unsupervised learning algorithm on this unlabeled data set, let's say it will produce two clusters. If I look carefully, I can try to find that these two clusters, maybe the images belong to this cluster, maybe of cat. Okay. And the images belong to this cluster, maybe of dog. Okay. But the difference is that here I am just providing the image and no label is being provided. Earlier, while I was providing this image, I was telling the model that this is the image of a cat. This is the image of a dog. I was telling, along with the image, I was giving its label, right? But now, when I am providing the image, I am not giving its label. I am just telling you take these images and do whatever you want. Okay, so no supervision. Okay, no supervision is being provided to them. Okay, them as in the models. Okay, so what it is, so what the definition says, let's see. The definition says unsupervised learning deals with unlabeled data. As I said, no label will be provided, only images will be provided. The objective is to discover underlying structure or pattern or representation without explicit target outputs. As I don't have any target output, okay, as I told, I don't know whether it is a cat or dog. I am just providing the image, and like my model is trying to find some structure or pattern based on those images. So this is called unsupervised data. To very on higher level, to separate supervised and unsupervised data, that is, on supervised data we have input images, not images, we have input, and corresponding to each of the input we are providing label as well, right? Corresponding to each of the input we are providing label as well. But in unsupervised learning, we are just providing the data. We are not providing the label corresponding to this data. On higher level, is this clear? What is supervised and unsupervised learning? In our course, we will only see this part, clustering, that is in later part of the week 3 and week 4. Even in today's session, we'll discuss about clustering. But there is no representation learning as a part of this course. Okay. The most important things you should be knowing is what is supervised learning, what is unsupervised learning. In supervised learning, what are two of its type? Classification and regression. In unsupervised learning, what is its type? Clustering. Does that make sense? Now just we'll look little bit into sequential learning. That's not at all important, as I told, but since that term was mentioned, right, in the third line, it was mentioned that sequential learning is also kind of paradigm. So we'll see how it is different from regression, classification difference. Once we encounter these terms, we'll discuss it. As of now, we are discussing the paradigms of machine learning. That's it. What are the three paradigms of machine learning? Supervised, unsupervised, and your sequential learning. That's now sequential learning on higher level involves decision making in dynamic environments where data arrives in sequence and decision may affect future observation or nuance. Okay. So, for example, if we think about some real world applications of sequential learning, is like your I can say stock market. Okay. So let's say I have a model. This is my model. Let's say this box is my model. So machine learning is nothing. We take input, right, and provide output. So this is like the basic thing of any ML algorithm, right? Our algorithm will take input and it will give us output, correct? So the thing that we are doing here can be either supervised, unsupervised, or sequential learning. So let's say this is my sequential learning model. So as I was telling, let's say I have built this model for predicting stock market data. Okay. So how will I provide data? Let's say I am dividing it into 15 minutes of split. Let's say my markets open at 9:30 in the morning. Okay. So I will provide data from 9:30 to, let's say, half an hour split. Let's say 9:30 to 10. Okay. I will provide data from 9:30 to 10 for, let's say, one stock of, let's say, some XYZ company. I'll provide data. From 9:30 to 10, it was performing this. This is my data I am providing into my model. And it had to predict what will be the price at, let's say, 10:50. Okay, based on my previous observation, that is the observation of the stock that it has performed from 9:30 to 10, my model has to predict what will be the output. Let's say the price of that model was, price of that stock was, let's say, 30 in first 10 minutes. Then let's say it was 32. Then let's say it was 34. Okay, in the last 10 minutes, let's say it was 34. Okay. Just on vague level, this thing doesn't work like this in the real life, but on vague level, this is what, let's say first 10 minutes from 9:30 to 9:40, the price was 30. From 9:40 to 9:50, the price was 32. Then 9:50 to 9, that is 10, the price was 34. Now the task of model is to predict the price of that stock at, let's say, 10:10. Okay. So after 10 minutes, what will be the price of that stock? So let's say the model is performing as 36. The model is giving me output at 36. So now after 10 minutes, it will be actually 30. After 10 minutes, it will be 10:10. So the price of the stock, let's say, it went down to 32. Let's say at 10 it was 34. At 10:10 it went down to 32. But my model have predicted that it will be 36, correct? So there is some mismatch. So this feedback, right? This feedback that you have predicted that the price will be 36, but price went down to 32. So based on that feedback, I will again feed this data. Now the data will be fed from 10 to 10:30. And based on that, my model will try to predict the price of the stock at 10:40. You are seeing that loop, right? It was mentioned that decision making in dynamic environment. Dynamic environment, it is keeping on changing. Like every minute, my data is arriving in sequence. right? From 9:30 to 10, then 10 to 10:30, then 10:30 to 11. So data is arriving in sequence, correct? And decision may affect the future observation or reverse. So as you see, it predicted 36, but it is telling like 32. Actually, the prediction of my model was 36, but in true sense, the price of the stock was came to 32. So based on this observation, I am again like adding feedback to my model, right? I'm adding feedback to my model, actually, not data. I am actually adding feedback to my model, right? And still at the same time, I am providing data, right, on sequence, correct? So this is what sequential learning is. I hope on higher level it is clear. It is not necessary if you are getting this 100% because this is out of scope of this course, as I told. But yeah, to sum up, sequential learning is nothing but your data arrives in sequence, and based on the output, your again your decision might keep on changing, because once you receive the output, you will try to compare with the real value, and that is the actual value, and then again you will provide feedback to the model. Hey, your like output was fake. It was actually supposed to be 32, but you predicted it as 36. But again, at the same time, you are providing more data, so you are providing data every time. It is predicting, and that's how the loop is going. Yeah, this is an example of stock market I'm doing. So in those situations, this sequential learning are being used. Okay. Is this clear to everyone? Okay. So yeah, that's it from this part. Now, if I go back to my presentation. So as you can see here, supervised learning means data, that is features and levels. As I was telling, features and levels, and I have to make prediction, right? What is this feature? As I like my data set have images. In this case, my features are images, correct? And then these levels are corresponding level, that either it is a cat or dog, correct? Okay. So then comes unsupervised learning. As I was telling, there only features are there and no labels are there, and my task was to find pattern. So these two slides are summarizing whatever I have discussed in this last 15 minutes, right? Now, as I was telling, from this image also you can try to remember what is supervised learning. A model is learning under some supervision. What is the supervision? That I have the images or input data, and I have to perform some task on this data such that I am mapping that input to output. So your teacher is, let's say, the model, for example, and your teacher, I shouldn't say teacher is the model. Let's say you are the model, and your teacher is giving you supervision that, hey, you have the data, you have to map this to output and try to find some function that it is able to do. Okay. But let's say you are trying to learn something from your own self. So you have just this notes or books. No supervision is provided to you. You are trying to find the patterns or learn something from yourself, right? So supervised means some supervision is provided to you. In unsupervised means you just have the data, no supervision is provided to you. You have to yourself figure it out. Okay. So that's the best example that I could have given. I think it is making sense. Yeah, supervision means the levels, correct. Mhm. So is the difference between supervised and unsupervised learning clear for you? Uh, Pratiksha, you cannot generalize that supervised is hard, unsupervised is supervised is easy, unsupervised is hard. You cannot generalize like So based on your day-to-day task or kind of task you have to do, you have to identify either it is a supervised task or unsupervised task. So based on that, you have to solve, right? You have to like know both the paradigms. Even going advanced, let's say if you are doing graduation in this domain, you will dive very much deeper into there are multiples algorithm, each of the type of ML paradigm have. For example, there are even nowadays this sequential learning, one of the most important learning, because many applications are there, because these things that computer vision or the like EV or the self-driving car, this actually comes under this supervised not supervised, that sequential learning. So these topics are actually so these paradigms from these topics are actually things of research or masters. They are pretty high level things. Okay. So I think like most of you guys have got, yeah, like difference between this supervision and supervision. Some of you have got partially, right? So you just do what I would say, just go through the lectures once again, or just go to Google or YouTube, maybe just type it out. Like you have to build this, what I can say, this intuition about or the, what I can say, like curiosity of learning, right? So you just go to YouTube or maybe Google and type it out. What's the difference between supervised or unsupervised learning? Just take up some articles from Medium or maybe Geeks for Geeks, or maybe like these are some renowned websites from where you will get actual learning. Maybe medium.com or Geeks for Geeks, or maybe towards datascience.com. This, if you just search it, you will find many analytics with this site. Many students have written many articles on these topics because they are very trending topics nowadays. And not only nowadays, it's almost like since half a decade, these topics are very trending. Like since last 3, 4 years, this machine learning have like boomed very much. And even going forward, the field of AI and this AI and all this machine learning is actually umbrella term inside AI. AI is a very huge field. This inside AI, there are this machine learning. Then there is one field is deep learning. Then there are some field as like computer vision, NLP, and there are many things. Okay, so yeah, you have to explore yours. Okay, so explain a bit more about unsupervised learning. Unsupervised learning is nothing. You have the data and you don't have any supervision. You just have data. Let's say you have 100 files, okay, or 100 images, and nobody is telling you anything. Just you have the images. Now you have to look into the image yourself one by one, and then you have to find pattern on that images. Okay. But let's say you have 100 images and you are giving the supervision that see on out of this 100 images, 50 are cat, 50 are dog. Now you have to do what? You have to separate, see the image and you have to say whether it is a cat or dog. So that thing is actually supervision, right? This thing is actually supervision. That someone is telling you that seeing the image, you have to separate out whether it is a cat or dog. But if someone is not telling you and just giving you 100 images, you don't know what to do, but you yourself have to find out the pattern. Okay, sequential learning is not very necessary to understand now. As I told you, this is not part of this course. Okay, so let's move forward from here onwards. Types of supervised learning. Now we'll see what are the types of supervised learning. So classification, regression. Okay, so these two terms all of you have already seen. Now I will discuss what each of the term mean, right? I think all of you have already seen these terms, right, in the previous slides, classification and regression. Okay, so now as I told, I give you data set and as I told you on this data set, I have data. Let's say 100 images, and all the images belong to either cat or dog, either cat or dog. So like this, there are 100 images are there. Okay, either cat or dog. Now the thing is that, like, now the thing is that you have to build a model that will classify either it is a cat or a dog. As a human, we know, as a human, once we look, like, let's say how our brain actually works. There is an image, okay? And we are seeing this image, and in our brain, let's say this is a brain, this thing as if this is a brain. And in our brain, after looking at this image, we will try to find some pattern. Like, let's say image of a cat is there. So after looking at that image of a cat, our brain will automatically distinguish whether it is a cat or a dog based on some features. Features such as maybe eye color is one of the features, or maybe shape of the nose, or maybe shape of the ears. These are features, right? After looking at the images, our brain try to extract these features, and after extracting those features, it try to it actually say, hey, it is actually cat. Or if it is image of a dog, after looking into the image of a dog, if my brain is trying to like extract the features of that dog and try to find the pattern, after that it will say, hey, it is the image of a dog, right? Correct. So that's how our brain actually works, correct? So we have this input, and our brain is, let's say, model, and it is giving us output as cat or dog. So this is actually classification. I am classifying. Is it a cat or a dog? Okay. I am classifying some based on the input that I have. I have to classify either one of the two. Is it a cat or is it a dog? Simple, correct? The levels are already provided to me that it will either be a cat or either be a dog. This is the level provided to me. Like the image that I am providing, it will either be a cat or it will be a dog. But my brain is actually classifying, seeing at the image that it is a cat or it is a dog. Clear? Okay. Then comes regression. I hope classification is clear for all. Then comes regression. So regression is, let's say, there the output was discrete. What I mean by discrete, like it can either be cat or dog. It has to either of these. In regression, my output is actually continuous. Continuous as in, if I give my model, let's say, last 10 days of rainfall data and ask it to predict how much rainfall it will happen tomorrow. It will predict, let's say, 33.33 millimeter. Correct? So how you can say, how am I providing levels here? So let's say it was day one, and I am giving some features. Let's say the feature is like the sunrise timing of this day, sunset timing of this day. Then maybe what was the wind wind speed this day? How is the weather? Whether is cloudy or let's say clear. So these are some of the features. And then at the end of the day, I am giving that, yeah, that day it rained actually 32 millimeter. Okay, that day it rained actually 32 millimeter. Then day two, same kind of feature, sunrise timing, sunset timing, right? Then at the end, let's say it was not raining, so it was, let's say, 0 millimeter. Similarly, for let's say 10 day, I have provided, and my task is that I have to predict what will be the rainfall on my 11th day. So some computation, internal computation it has done, and it is giving me output that 33.3. So these things are my input. Okay. These features that I have given is my input, and my level was that first day it was rain 32 millimeters, second day it has rain 0 millimeter, third day it has rain 34 millimeter, let's say. So something like that, right? Some real number I have provided, correct? And based on that, it is giving me output as some 33.3. And it is possible that there was no possible 33.33 value here, right? So my task is like some what I can say, like I have to predict something real value. This is one of the thing. Like, for example, if I take the example thing given here, this can be splitted into two things, like both for classification and for regression. So if I ask you, like, based on this rain, so the classification problem can be something like that. whether it will rain tomorrow or not. So you see, as I am classifying something like yes or no. So this is a classification problem. Okay, let's say it will be raining tomorrow. Yes, let's. Now this problem can be converted into regression. How much millimeter will it rain tomorrow? So the output will be something, some real value, correct? Output will be some real value, right? So this supervised learning, we have split it into two types, classification, regression. On classification, we are classifying either yes or no, or for example, cat or dog, or maybe some image I am providing and asking whether tree is present in this image or not. Some email I am providing, I am asking, is this email spam email or non-spam email? So this is some classification problem. Some image of, let's say, some extra I am providing and asking my model whether this person has this XYZ disease or not. So it is either yes or no, like either this one or that one, either this one or that one. But for regression, it is something different. It is like giving me output something as real value, right? Okay. I hope this is making sense for all of you. Now, some question time. If we have to predict whether loan should be given to a customer, what type of task is it? Whether we should be giving him loan or not. It's quite strange to see how many of you are giving regression. How is this regression? It is clearly asking to whether loan should be given to a customer. So there can be two possible cases. Either it will be given or it will not be given. So this is class, you are classifying, right? You are classifying whether the loan should be given or not. This is very simple. We have to predict whether we should be like read the sentence again and again. If you have to predict whether loan should be given to a customer, so what could be the possible outcome of this question? The possible outcome would be either it should be given or it should not be given. There is only two possible outcomes, right? Yeah. Already 184 people have responded. Once it crossed 200, I will support. Okay. So yeah. Out of let's say 201 people responded, 157 of them have given both as regression classification and rest 44 as regression. So this is a classification problem because the answer to this question can either be yes or no. This person can be, the loan can be given to this person or it will not be given, right? So this is I am classifying. Okay. Now moving to the next question. If you have to, before answering, just read it carefully. If we have to predict how much loan should be given to a customer, now say, can you say like how much loan should be given to someone? In this, the output should always be some real value. Real value as in it can be 10,000, 20,000, 30,000, 40,000, 50,000, anything. But it will be some real value. Real value means number. This number can be 0 to infinity. Right? This number can be 0 to infinity. So by looking into the statement, you are easily able to say like it is a regression problem or classification problem. If you have to predict how much loan should be given to a customer, what type of task is it? So almost 175 people have responded, and I think now, like if I find the ratio of correct response is quite high, right? Almost 160 people have responded regression, and around 20 people have responded classification. Right? I think you guys are now getting what classification and regression is. Okay, so I think I should move forward. It's already 5:50, and I am yet to discuss many. Yeah. So now comes under classification, there are two types, or maybe forget two types. Just think, if if the output matters to me, or the order of the output matters to me, ordinal classification. If it doesn't matter, it is just classification. I am not telling is it ordinal or not. Okay, if order matters to me, it's ordinal. Okay, that is the target has some order. For example, grades. If I discuss about grades, let's say in a class, there can only be, let's say, 5 grades possible. It can either be A, B, C, D, and E, right? So here you see order matters. How the order matters? Because the grade can be anything out of this 5. Grade can be anything out of this 5, right? It will not be anything outside this 5, right? It can be either A or B or C or D or E. But order matters because we always know the grade A is always higher than grade B, right? Grade B is always higher than grade C. Grade C is always higher than grade B. And grade D is always higher than grade E. Does that make sense? That order matters for grading? Okay. So predicting spam versus non-spam, whether my email is a spam or non-spam. So here will the will it matter whether will the order matter for me at all? My email can either be spam or non-spam. What to do with the order on this case? Like I am not getting. Why should my order be matching? Is spam email have some higher respect than non-spam email, or non-spam email have some higher respect than spam email? It doesn't make sense at all. I have to predict whether I have received some mail, whether is it a spam or non-spam. That's it. That's my purpose. Okay. Those who are yet to respond, please respond to this by joining this menti.com and using these code 77448640. Because I can say 366 participants are there, out of which 307 have joined, and hardly half of them are responding as of now, or maybe 70% of them are responding. I hope this is clear to all. This is a classification task. Yeah. Now moving to the next question. Predicting grades of a student is what kind? Now, as the example that I have given, here our orders actually matter. It is a classification, no doubt, because only out of the 5 it will be possible, right? let's say someone is predicting marks of a student, it will be regression. Because the marks can be anything 67, 68, 69, 67.5, for that matter 75.3, 82.9, anything like that is a regression. But here I have to predict the grades. So it is a classification. Now in this classification, my orders actually matter. As I have told you, A is greater than B, B is greater than C, C is greater than D, D is greater than E. So this is, you just have to answer whether it is a regression, classification, or ordinal based on your understanding. Yeah. So almost 170 plus, that's not 175 near about. And almost 150 people have responded it correctly. Ordinal classification. Some of you have responded classification, that's well. It is classification problem as well. But here the order matter. That's why we are taking specific type of classification, that is ordinal classification. And it is not regression problem at all. Because we are predicting grades. We are not predicting marks. If we are predicting marks of a student, it would have been regression problem, right? But we are predicting grades here, where the order is met. So this is the ordinal classification. So yeah. Now, as I told, this was almost 80% of the week 3 lectures. Remaining 20% and going forward week 4 is about clustering. So today we'll be discussing a very specific kind of clustering, that is K-means clustering, and some like different kind of clustering is there that will be discussed in the week 4, because that are part of week 4 lectures. Okay, so to discuss K-means clustering, what we have is this image of a fruit is given to me. Look this very carefully. This is image, right? Input. And I cannot associate any level to it. Like I know this is an image of a fruit, but here you can see apples are there, grapes are there, banana are there, right? Correct. Now, this thing I was telling, you have to yourself find out which is apple, which is banana, which is grapes, and you have to keep them on separate clusters. Okay. So based on this, do I have no? Wait. So based on this, can I say like which of my cluster is actually making sense, B or C? Based on this A image, if I try to find pattern, which is actually making sense, B or C? In B, I have, you can see in B, I have how many clusters? 3 clusters, and on C also I have C cluster, 3 clusters. On the first cluster of B, let's say this one. Let's say this one, okay? This cluster I'm talking about. We have banana, banana. This is, let's say, second cluster. We have grapes, grapes. Third cluster, we have apple, apple, apple. Okay. Okay. So this is B. Many students are telling B. Many are telling both. Okay. Now here also in the C, you can see that something is common between them. It may be apple and it may be banana, but a clustering is done based on color here. Yellow fruits are clustered together, orange fruits are clustered together, green fruits are clustered together. Since no supervision is provided to you, there might be possible that one student is coming up with this cluster, another student is coming up with this cluster, but both of them are correct, because you are classifying or you are clustering based on the type of the fruit, and maybe your friend is clustering based on the color of the fruit. So both B and C are correct cluster, because no supervision is there. So what is there to judge us, like whether it is a correct or not? Since no supervision is there, so both of your clustering are correct. One is done based on the type of the fruit, another is done based on the color of the fruit. Is this clear to all? Okay. So yeah, now we move forward. Google Photos app automatically group our pictures, correct? If we go into the Google Photos, we can say it is grouping. So now say whether it is a regression, classification, ordinal classification, or cluster. Let's say on your mobile phone, you have images of 10 of your friends, and each of them have 100 images. Let's say your friend 1 has 100 images, your friend 2 has 100 images, your friend 3 has 100 images. So all total 1000 images of 10 friends, right? Now Google Photos will cluster that into 10 groups, and based on the same facial feature of those people, right? So that's clustering. Grouping of the picture is done based on the facial features, and this is clustering. I'm thinking, how can someone think about this is a regression problem? No way possible this is a regression. And this clustering comes under those who are riding on chairs. This clustering comes under what? Supervised or unsupervised? Let me know. Correct. Unsupervised learning. Those who are saying unsupervised learning, it's correct. Because under supervised learning, it is regression and classification, and under unsupervised learning, it's clustering. Yeah. So almost 180 people have voted, and surprisingly, the ratio is very good here. If I find the ratio with like correct option along with the incorrect option. Out of 180 people, almost 172 have 173 have responded clustering. That's quite a good number. That means that the session is making sense for you all. And I am judging based on the data, because we are learning about data science and machine learning, right? And AI. Okay. So moving forward, we have the kind of clustering that is K means clustering. Okay. Now what this K means clustering is? K means clustering is a clustering algorithm. Okay. So there are two steps involved in this. One is this pivot step or pivot step, whatever you say. This pivot step, and another is this cluster step. Then again pivot step and then cluster step until all of my data points belong to same cluster are clustered together. Okay. You see this algorithm which will stop once all of our data points belonging to same color are clustered together, right? Once they are clustered together, this algorithm will be stopped. So let's say I have this many data point, okay, this many data point, and randomly I took 3 data point. Let's say this is a data point and I am assigning it color yellow. This is a data point I am assigning it color brown. This is a data point I am assigning it color green. This is random. You can even select this one. It doesn't even matter. You can select this one and assign it green. Okay. So the thing is that this is done at a random. Anything that you want. Okay. Now I have to look to the near about data points. Okay. So this data point is nearest to yellow or green or this brown. This one. What do you think? Let me know in the chats. just visually, because on calculation I will do it mathematically. That's not part of the course, but visually, what do you think? It is nearest to brown, right? Someone is telling red or brown, whatever it is. Yeah, brown. This data point, is it nearest to yellow? Is it nearest to brown, or is it nearest to green? Again, brown, correct? So we'll assign this brown. Now this data point, is it nearest to yellow? Is it nearest to green, brown, or is it nearest to green? It is nearest to yellow. So let's see if out of this data point, you can see the data point, whichever it is nearest to, we are assigning the color to that data point. Correct? Similarly, for these data points, we'll do, it is nearest to green, right? It is also nearest to green. Like it's, I pick up this data point, I check whether it is nearest to yellow, or is it nearest to brown, or is it nearest to green. So I can see the distance between this data point and the green data point is like least. That's why I am assigning it color green. Similarly for this one, and similarly for this one too. Correct? Now this data point. On this data point, I am seeing whether it is nearest to brown, or nearest to yellow, or nearest to green. So I can see the distance is least in the green. I am assigning this green color, right? And then remaining all the data points, same thing we'll do. Find the distance, and I'll see it is nearest to brown. So all these data points actually nearest to brown as compared to distance between yellow and green. Okay. So this is brown. Okay. You can see that. Now, similarly, again, I have pivot step and cluster step I have done once. Now we can see that on my cluster, all the data points are of not of same color. Now I will like reset all the things. I will just reset all the colors, and again randomly, as I was telling, randomly I will again pick up some data point and assign them 3 colors. Let's say this data point I am picking now and assigning it yellow. This data point I am picking and assigning it green. This data point I am picking and assigning it green. So now again, what I will do, I will try to find the distance between them. And once which data points are nearest, I will just club them together. This data point are nearest, I'll club them together and give yellow. This data point are nearest, I'll club them together and give green. This data point are nearest, I'll club them together and give brown. So now you see, once all the data points that are nearest to each other are clubbed together, and they're taking the color of they're taking the color of this correct pivot. At that point of time, we can say that our algorithm has actually converged. Okay, our algorithm has actually converged. So this final diagram, you can see in this cluster, only same color of data point are there. Here also in this cluster, only same color of data point. In this cluster, only same color of data point. So this is very clear, I guess. And those who are spamming, I'll urge them not to spam anything on the like yoga and TV keyword spamming, right? So please don't spam anything. Okay. So that will not be helpful for others as well as for you. Please try to maintain the decorum. Okay. Because you are spamming, I will turn off the chat, and it will create like disturbance for other students. They will not be able to ask their doubt. So better show some respect in this kind of public places. So I hope this clustering is clear for all of you, right? Right. What is this like? Forget about the maths. Math is not that much important, or not a part that depth maths is required in this course. If you are going forward, if you do degree or maybe graduation or masters in this machine learning, AI, computer, that's a subsection of computer science there. If you do masters in this domain, then you have to dive deeper into the mathematics behind it. But as of now, I think it is making sense how these things are working theoretically. I must say theoretically here, because this or conceptual will be perfect word. The concept behind this algorithm are clear for you now, right? The mathematics behind this algorithm is not necessary, because that's not a part. This k-means is not a hit and trial method. There are many ways to initialize, right? This thing I am doing random initialization in this course, but there are many ways. I shouldn't even name them. Many of the students might start asking. For example, there is a type that is k-means plus plus. That's not at all important or part of this course. But yeah, as of now, you think that we are just doing randomly initializing this data point, right? And then trying to find the nearest data point and assigning those data points the same color of the data point. As I told, if some data point is nearest to brown, then this data point will be colored as brown. And at the end, I will try out with each of the data points until and unless I am finding some cluster that is all the data points are belonging to same cluster. If I have find after, let's say, 3 times, thereafter 2 times we have already got, right? Like first time I have selected this, if I go it, first time I have selected these 3, right? This is first time, this 3, and we have got this cluster, okay? This cluster. You can see this cluster, not all the data points are belonging to same cluster. But this second time I have selected these 3 data points. And after this second iteration, so this was my first iteration, right? Pivot step and cluster step done. Then in second iteration, you can see after the second iteration only, I have got these clusters together. Sorry. I have got these clusters together. So only in 2 iteration I have able to find it, right? So yeah, let's say now lakhs of data points are there and you have to find 1000 clusters. So that's very computationally heavy, so much permutation combination you have to try. So for that thing, we have some better algorithms, but leave that as of now because they are not part of your course. So on higher level, this clustering is what this was main purpose. That should be like, you guys should be clear what clustering is. And I think it is clear for all of you what actually this clustering is. Yeah. So what are the limitations of this k-means clustering? So the limitation is that from the beginning of the algorithm, we have to decide what should be the value of this k. Right? We should be knowing how many clusters we should be separating. This k is nothing but how many clusters. So see, in this case, in the previous case, if I call this algorithm k-means algorithm, so what should be the value of this k? By looking into these clusters, what you can say? What should be the value of this k? K means number of clusters. Okay. So what should be the value of this k? Yeah, Dikshit have told 3. Yeah. So it is actually 3 means clustering, right? Because at the end of this algorithm, I am getting 3 clusters. So it is actually 3 mean algorithm because I am replacing k with 3. So 3 means algorithm. Okay. So the limitation is that I must know the value of the k. And as I say you, these are spherical clusters. Okay. So sometime might happen the spherical decision boundaries. These are decision boundaries or cluster. As I was telling, like generally my clusters are like this circle. Any data point lying inside this circle will be of that color. If say some data point is here, let's say, then it will also be yellow, right? So any data point lying in my decision boundary, this is my boundary. Okay. Any data point lying inside this circumference of this circle will be of that color. Any data point lying inside the circumference of this circle will be of green on. Let's say any data point is there. So what will be the color of this data point? What will be the color of this data point? Green. Correct, correct. Any data point lying inside this decision boundary, it will be again brown color, right? So yeah. So this is one of the limitation actually. Why it is limitation going forward, you will see why it is limitation, but yeah, it is. The cluster is spherical and there is mathematics behind it, why it is spherical. So let's not deep dive into it because that's not necessary. The concept is necessary, not the mathematics behind it for this entire group. Yeah. So the limitations are it requires the value of k and it is spherical cluster. So you see this cluster, as I was telling, this is spherical, sphere in shape, right? If you see this, all of the clusters are sphere in shape. Any data point lying inside the boundary of this sphere is actually that color. So yeah, you see, if I try to draw a sphere here, let's say some sphere here and sphere here. So there is confusion. We cannot do that correctly, right? Because these data points are lying in this cluster. Let's say this is cluster 1, this is cluster 2. And these data points are also. So they are lying on this, both of this cluster, correct? So this is actually limitation. If they are actually being colored as red, but they are lying in cluster 1. So this is wrong classification. If they are actually lying on this cluster, but they are colored as violet, this is wrong classification. Okay. So this is one of the limitations. We will not deal how to deal with this limitation. So that's just for letting you guys know the thing that I was telling, that since the decision boundaries are spherical, so I think my screen is visible. Samar, it is issue with your network because I think my screen is visible to us. Yeah. So the thing I was telling, this was the limitation that spherical decision boundaries, right? And we cannot easily like find the decision boundaries or the data point, right? Okay. And then same thing here also. You see, if I try to find like split that into two parts, that is sphere, like this. Like here is one sphere, let's say, another is another one is one sphere like this. So all the data point lying here should be of your like blue color, you can see, and all the data point lying here is actually orange color. This is my k-means will actually output. But if I look carefully, you can see that this is not the case. Truly, all my data points lying here should be of orange color, and all my data points lying outside should be of blue color. So I am telling that the actual clustering should be done like this way. But if I run k-means algorithm on this data set, my model will produce this output. But this is actually wrong, right? Because I want this kind of clustering, but model is doing this kind of clustering because of the spherical nature of the decision boundaries, right? This is not correct. So this is the limitation of my k-means algorithm. Okay. Now some quizzes. So all of you get ready with your Mentimeters. Okay. We'll solve some few questions and then we'll be done in this session. Okay. Okay. Which of the following is an example of unsupervised learning? Unsupervised learning, grouping customer by purchasing behavior. What do you think? Correct. Clustering. I don't know why it's much like vague output. Many 35 have answered cluster grouping customer by purchasing behavior. As I told you, grouping means clustering, right? So clustering comes under unsupervised part. Predicting house prices on features. This is a regression problem because I am predicting some value, right? Some dollar, maybe $100 or lakhs. If I say in terms of Indian rupees, maybe 20 lakhs or 30 lakhs. The third problem is classifying emails as spam or not. This is our typical classification problem. Identifying whether a image contains cat or dog. This is again also classification problem, right? So only the first option is correct. Get ready for the second one. Second question. All of you ready, right? Where is it? Binary classification means only two possible outputs. Identifying handwritten characters, there are 0 to 9 characters, so this is not binary at all. Approving or rejection of a loan, labeling news article by topic, or predicting academic grades. So option B, I guess. Yeah, correct. Only two possible outputs, either yes or no. Right? Only two possible outputs, yes or no. So binary means two. More than two is multi-class. For example, identifying handwritten characters. So only the possible output here are 0 to 9. Like it can either be 0 or 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8 or 9. So that's multi-class, more than 2. Anything greater than 2 output is multi-class. Labeling news article by topics. So topics can be multiple topics. Predicting academic grades. So it is an ordinal classification, but multi-class because the grades can either be A or B or C or D. So it is more than 2, right? So yeah. Next question. Get ready. The question, which of the following is the example of regression? So my value should be real value. My output should be real value. Identifying spam mails, clustering customer segment, or predicting house price. Very easy. I believe all of you will be giving correct or right answer. Predicting price of a house or clustering customers or identifying new. Most of you have given correct answer. Yeah, regression, because I have to predict the house price. Price is something real value. As I told you, I have already given you the example. It can either be in lakhs, right, or crores or something like that. It will be some value, 1 crore, 2 crore, 3 crore, something like that. Identifying spam email is our classification. Clustering is our unsupervised learning, right? Clustering customer segment. That's clustering algorithm. Yeah, gets ready for the next question. And here it is. In a supervised learning model, if we are building a system to detect whether a mail is spam or not, what type of data would we need for training? Only the email contents without labels, email with labels indicating spam or not, or only the email address. In supervised, label is necessary. In supervised learning, label is necessary. Correct. Only the email content without label. If it was the case, then it would have been unsupervised problem. But our setting is actually supervised problem. So we need emails along with its label, right? So yeah, the performance is quite good for you guys. You're giving quite fast answers, and the answers are also good. Yeah. Okay, question. So here is the question on your screen. Which of the following is an ordinal classification? That is order method. Predicting person's favorite color, categorizing product as electronics, or rating customer satisfaction as low, medium, and high. Where order actually matters. Rating customer satisfaction as low, medium, high, or categorizing product as electronic, clothing, or furniture. Correct. Rating customer satisfaction as high, low, and medium, because you know your order is matter because high is greater than medium and medium is greater than low. Just simple thing, right? Good, good, good. Then next is so next question on your screen. Answer quickly. Clustering is a type of which type of learning? Supervised, unsupervised, or sequential? All of you, I hope all of you will be answering this one correct. At least I want 100% correct answers. Clustering is supervised, unsupervised, or sequential? Jam, how become clustering is supervised? These things I have told it's almost more than 10 to 12 times today only in this session. In supervised learning, we have regression and classification. Clustering is unsupervised learning. And sequential learning is not even important for this course. Seventh question. What does K in K means represent? K. I have discussed already. Number of cluster or number of iteration or number of data points. I have already told what will K mean. in this K-means. Correct, number of cluster, as we have seen, right? In K-means algorithm, the number of cluster is actually given. Quite a good like output. And that's ready for the 8th question. In K-means clustering, how is the number of cluster determined? Automatically determined by the algorithm, specified by the users based on the number of features or based on the size of the data set. Who actually decides scale? How many cluster I want as a run of this algorithm? Who decides? Yeah, as a user, I have to decide, right? I have a data set and I will decide whether I want 2 clusters, 3 clusters, 4 clusters, or how many clusters. Okay. Yeah. So, 9th question on your screen. I'm doing it quite fast because it's already 25 minutes above 6. I have to conclude the session by 6:30. So which step is performed repeatedly in k-means clustering until convergence? Calculating distance between data points and pivot, assigning data points to the nearest cluster, or updating cluster means based on the mean assigned data points, or all of the above. Correct, all of the above, because I was telling you pivot step, then calculating distance, and then assigning to the nearest cluster. Again, pivot step, calculating distance, assigning data point to the nearest cluster, right? All the steps in a sequence, one by one. So, calculating Euclidean distance between, first we have to select the pivot, then calculate the distance, then we have to assign the nearest cluster, right? Second last question on your screen. What is the role of pivot in k-means clustering? What does this pivot do? To represent center, to assign new data point to cluster, to calculate the distance between cluster, to level data point. What do you think actually this pivot in our k-means clustering is doing? To represent the center of a cluster. Each of the pivot is actually representing the center of a cluster. Okay, in the first step, we are doing random assignment. In the second step, we are calculating mean, and based on that, we are deciding the pivot element. And the last question for the day. Which of the following is limitation of k-means with respect to the number of clusters? It automatically determines optimal number of clusters. No. It produces non-spherical cluster. No. It requires user to specify. Yeah, option B. I think option B. It requires the user to specify number of clusters before. Else. Okay. So, if I look into the leaderboard, yeah, Akash is actually the winner. Good, congratulations, Akash. I think your concepts are clear on these topics. Let's go to them over some, I can say, articles and all over Google, or maybe just revisit the videos, or maybe to this session to get more in-depth clarity. And I will request all of you to do so this thing. Okay. So it's already 6:30, almost 1 minute left. So did you find the session useful? Just let me know. I think those who have watched the lectures and then coming to the session, it was quite useful for you guys, because we have almost all total 10 to 11 quizzes and few more questions almost 14 to 15 question we have discussed today and those topics on some higher level. Yeah, that's it. So almost 150 responses, and out of which almost 100 people have found it. What is that one thing that you have like learned from the session? Or key takeaways from the session? So you have seen that is better than school and classroom and supervised regression training paradigms. Okay, yeah, that's it. That, that's all for today's session. It's almost 6:31 p.m. Yeah, that's all from me. Correct? Yeah. So today we have discussed week 3. And the next session, I urge all of you before coming to the session on next Saturday, watch the lectures of week 4, and hopefully Prashasti will take the session. So you can ask your doubt related to week 3 and 4 in that session. Okay, that's it. That's all from my side. Thank you. In case you have any doubts, you can ask on the Google forum. I'll try to reply tomorrow by tomorrow on the forum. Okay, you can ask your doubts there, and so I'll just look into the doubts and reply to. I cannot take any more doubt today because it's almost 6:30. So thanks all for attending the session. We'll again speak maybe or after that. Thanks. Just ask your doubt on the Google forum. Yeah, Dhanalakshmi ma'am, are you there? Dhanalakshmi ma'am. Someone from the school connect team here.